Hi, welcome back to Intermediate Algebra. Today we're going to look at something called variation. Basically, variation, it's used for a lot of real-world kinds of situations. One example would be how much money you make when you work. That's a direct variation. The more hours you work, the more money you make. So that's actually the first kind of variation we're going to look at here, what's called direct variation. In a direct variation setting, if one variable goes up, so does the other. And they go up together in a very set and easy to figure out manner. And so that's what we're going to look at, how you figure out what happens to one if you change the other variable. So for direct variation, we're looking at something along the lines of y varies directly with x. And we have a little equation that we can use to work with that then. It's y is equal to k times x. Now, importantly, and this is going to be true all the way through this section, even as we go into the other kinds of variation. But importantly, when we say y varies directly with x, the variable that goes first here that says y varies directly, that's the one that's going to go by itself. So you'll see down here I have y is equal to k times x. If I just switched it and said x varies directly with y, we would also have to switch them here. Okay, the variable that's doing the vary, y varies, that's the one that's going to go by itself. So that's something to keep in mind because you have to be careful and pay attention and make sure you have your variables in the right place. So what is this k thing that we have down here? Well, k is what is called the constant of variation. And so it's there, and the wonderful thing about k is if you have a given situation, once you know k, it doesn't change. And so what we're going to see in this section are a lot of problems where you have two sets of information. You have all the information about one part of the problem, but then you are trying to find information in the second half of the problem. And so to do these problems, we're going to do these basically in two steps. And if you take the time and set them up, they go really well. If you don't take the time, all kinds of weird stuff happens. If you take the time to set them up, just like I'm going to show you here in a minute, they go really, really well. So let's look at the steps that we actually have to cover. Pretty straightforward. We're going to use the initial information to find k. K is that constant of variation. We're going to find that first because then it is set. If k is 2, k will stay 2 for that whole problem. And once we have k, then we're going to come back to that equation again, use the second half of the information to find the requested variable. So let's do an example and I'll show you what I mean. Okay, so here's our first example. It says if y varies directly with x and y is equal to 6 when x is equal to 2, find x when y is equal to 13. So again, we're going to be working here with y is equal to k times x. And I know that the y is by itself because the problem tells me y varies. That's always your tip off. That's the one that goes by itself. So I'm going to run through this in two steps. Neither step is terribly hard, but it's really important that you do them both because all sorts of weird things happen if you try and skip that first step, which I'll be honest, a lot of people try to do. So don't go that route. It only takes a minute to go through this whole thing. All right, so I take the first bit of information. I know that y is 6 when x is 2. That's the first half of the information. I have both x and y. And so what I do is I take that 6 and 2 and I plug it in, giving me 6 is equal to k times 2. I divide by 2, and now I know that k is 3. Once I know k, it's stuck. That's the value for k. So then I go on to step 2. Now I can find x when y is 13. So I put the 3 in for k, then I put the 13 in for y, and I divide by 3, and it turns out that x is 13 over 3. Two relatively straightforward steps that we can do. So there you go. There's a good example, and we'll do some more. Okay, so here on this board, we have some more direct variation possibilities. Sometimes the variation is just a little bit more complicated than just plain y and x. So some other things that you might run into are y varies with the square of x, which would look like y is equal to kx squared, the cube of x, which would be y is k equal to k times x to the third, and the square root of x, y is equal to k times the square root of x. So notice that in all these cases, it's still the same basic setup. It's just that the x part has changed just a little bit to match what was over here in these directions. So pay attention and be careful. Make sure you get the right stuff in there. That would be good. All right, in the next board, we're going to move on and look at inverse variation. And so let me get that ready. All right, so next up, indirect or inverse variation. In this case, as one variable goes up, the other one is going to go down. And a really nice real-world example of this phenomenon is a campfire. If you've ever sat out around a campfire or a bonfire or something like that, you know that as you get closer to the fire, the hotter it feels, right? So the smaller your distance, the greater the heat, and if you turn around, as your distance gets bigger, the amount of heat that you feel is less. That's a great example of inverse or indirect variation. This form will be y is equal to k over x. So we're going to go through the same process. We're still going to start by finding k using the initial information, and then we'll use it to find the variable that we would like to find. So I have actually a little bit complicated example here for us, and it's going to be lots of fun. So let's take a look. It says if y varies inversely with the square of x and y is equal to 2 when x is equal to 2, find y when x is equal to 7. Okay, so a lot of stuff is happening here. First, it is inversely, so we know we're going to be looking at this kind of setup. Y is equal to k over x. The y is by itself because y is varying, but this time it's varying with the square of x. So you'll notice when I started to fill out step 1 here, and I probably should have written just a little bit more, we're going to have y is equal to k over x squared. That's what we're working with here. So when I plug in the 2's, I plug in the 2 for y, and on the bottom I have 2 squared because, again, it's x squared on the bottom. 2 squared is 4, so I have to multiply both sides by 4 to get the k by itself, and that gets me that k is 8. So again, I square the 2, that's 4. To get rid of that, I multiply both sides by 4, and that gives me 8. Once I have 8 for k, I bring that over, and now I'm going to find y when x is 7. So I know k is 8, so I put that in on top. On the bottom, I'm not going to forget the square. That's a real easy thing to forget here. A lot of people do that. Be careful. 7 squared is 49. So in this case, y ends up being the lovely fraction 8 over 49. And definitely, please leave that as a fraction. That's really nasty as a decimal. All right, so let's keep going. We have a little bit more here to talk about, but we're getting there. All right, so the last thing we have in this section is joint variation. Joint variation is direct variation with not 2, but 3 variables, making it so much more fun. I'm being a little sarcastic. I know it just makes it worse. Anyway, so sorry. Y varies jointly with x and z. Again, the variable that's going to go by itself is the one that varies. So in this case, it's y varies, so y is by itself. Notice now we have y is equal to k times x times z. So y is the one that is connected to the other 2. If x goes up, y will go up. If z goes up, y will go up. If you just make x get bigger and y stays the same, z would actually have to go down. So don't try and think that those two are going up together. They're definitely not. All right, but here's our example. If x varies jointly with y and z, and x is equal to 12 when y is 2 and z is 4, find x when y is 3 and z is 5. That's a lot of information. So again, be careful. Cut it into parts. We can see the first part here. X is 12 when y is 2 and z is 4. Okay, that's the first part. We're going to set this up the same way. We're going to start by finding k. Notice that in this case, we have a little bit different kind of thing going on because now x varies. So x is the variable that's by itself, and we have k, y, z on that other side. So I plug in the numbers. 2 times 4 is 8, so we end up with 12 is equal to 8k. If you divide both sides by 8, you get 3 halves. 1.5 would also be perfectly acceptable. I just like fractions, so I left it like that. But anyway, now we have k. Again, once we have k, we can bring it over, and we can do the process to find the variable we actually want. In this case, we want x when y is 3 and z is 5. So I plug in 3 and 5 for y and z. You'll notice I put 1's underneath the 3 and the 5, so I have fractions, so I can just multiply across. I get 45 on the top, 2 on the bottom, and that's my answer, 45 over 2. In this case, you could absolutely tell me that it's 22.5. That's a wonderful decimal. I don't have any problems with that. But if it's an ugly fraction, please leave it as a fraction. We definitely don't want nasty-looking decimals. All right, so there you go. I guess the only thing that's left to say here, and I'm just going to be real brief with this because this video is already kind of long. The last thing I'll say here is we could still combine direct variation with inverse variation. So you can have something where you have both a letter on the top and the bottom. Something like y is equal to kx all over z. So the kx would give you the direct variation on the top. The z on the bottom would give you the inverse variation on the bottom. So feel free to look in your book and check that one out. Here's a hint. Still works the same way. You set it up, you find k, then you go back and find the variable that you want. So have a great day. Thanks.